Hi, folks, and welcome to the PASS Marathon for Predictive Analytics use cases. We're excited that you could join us today for Dean Abbott's session, Turning Membership Surveys into Action with Predictive Analytics. This PASS Marathon consists of 5 consecutive live webinars delivered by expert speakers from the PASS community. The sessions will be recorded and posted online after the event, probably by the end of the week, and you should receive an email letting you know when the recordings are available. My name is Matt Gordon. I'm a data platform solution architect for DMI, but you're not here to hear about me. So let's get into some of the introductory slides before I hand the reins over to Dean. First off, as the slide says, if you require technical assistance, please type your question into the question pane located on the right side of the screen, and one of us will assist you. This pane is also where you may ask any questions throughout the presentation. Also, feel free to enter your questions at any time, and once we get to Q&A portions of the sessions, I will read your questions aloud to Dean. You are able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note there will be a short evaluation at the end of the session. Your feedback is very important to us, so please take a moment to complete it to let us know what you thought of this. This will pop up after the webinar ends in your web browser. I'd also like to take a moment to thank our presenting sponsor, Kingsway Soft. The staging of PASS Marathon would not be possible without their generous support. They are the reason this event is available to all of us free of charge. If you'd like to learn more about our sponsors and sign up for information on how they can help you, please visit the sponsors page of the PASS Marathon website. Also, PASS Summit is the PASS community's flagship event, and it is happening this year, November 6th through 9th in Seattle, Washington. PASS Summit is the largest conference for technical professionals who leverage the Microsoft data platform. So definitely show up and immerse yourself in deep dive technical sessions, learn best practices, and discover new tips and tricks. For more information and to register, please visit passsummit.com. And now we'll learn a little bit about Dean. So this PASS Marathon session is presented by Dean Abbott. Dean is co-founder and chief data scientist of Smarter HQ. He holds a BS in mathematics of computation from Rensselaer and a Master of Applied Mathematics from the University of Virginia. He is an internationally recognized data mining and predictive analytics expert with 3 decades of experience applying advanced data mining algorithms, data preparation techniques, and data visualization methods to real-world problems, including customer analytics, fraud detection, risk modeling, text mining, survey analysis, plan giving, and many more. And so without further ado, here is Dean with Turning Membership Surveys into Action with Predictive Analytics. Dean.
Thank you very much, Matt. It's always a real pleasure to work with PASS. I've done these marathons before. I've spoken at PASS business analytics events and love working with them. Before we get started though, one thing I'd like to do is start with a survey just to get a sense for who is here and what kind of experience you have. And there's a poll questionnaire asking how many of you have built predictive models in your past. And I guess we could do it over your entire career, either never, a few times, or you do so frequently, like you're an experienced kind of modeler. So we'll let those answers come in. One of the interesting things to me about this space is that while predictive analytics, data science, AI, machine learning, all these related fields are so much more in the news these days and on the minds of stakeholders and businesses, it's really not very new. I mean, we've been doing the same kinds of things for decades. I've personally been building models like the ones I'll be describing today for 3 decades, and the algorithms, the math is essentially the same as we've seen throughout those 30 years. But it's great. We have such improved data infrastructure. We have more data sources and more horsepower, especially with cloud computing, to be able to build these models from. So what do we have from the survey results there, Matt?
So we do have results, and ironically, the rounding was done by GoToWebinar, not to me. The rounding's a bit dubious, and you'll see why here in a second. So 58% of the respondents said they never had, 38 respondents said a few, and 5% said I do this frequently, which actually brings us to 101% voting, which is a bit strange.
Well, which is good because we're more than 100% engaged here. I always love to do that. So that's not, that kind of breakdown is not atypical for these kind of events. I'm especially happy for those of you who have not done this before. I'm hoping this will be motivational, that there'll be enough connective points for you to understand why the approaches I'm describing here were taken, and maybe an entry point with some terminology and some approaches that you can latch onto. One thing I will mention too, I am not going to talk very much about the algorithms themselves. I'm going to talk about factor analysis and linear logistic regression and decision trees. But even if you don't understand exactly how they're built, at least this will give you some motivation to how they can be used. So this talk was it's something that I've done before. It's related to the YMCA. If you're a member of a YMCA, you know exactly the survey I'm referring to. They've been using a survey for 20, 30 years that's 65-ish questions that summarize member interests, member experiences with YMCAs. And I'm going to first describe the more traditional approach that statisticians might take with survey analysis. And the second solution is trying to align the interpretation of the surveys more to the business objectives and make it more transparent for the decision makers. So here's the question. The member surveys, question number one in the membership survey is, how satisfied are you with the YMCA, with your experience with the YMCA? And that's a typical first question. You see surveys, the overall satisfaction numbers, and we had 38,811 surveys with these answers. There are a few demographic data points that will self-report on the surveys. Mostly though, the surveys were asking questions like, is it good value for the dollar at the YMCA? Does the staff know my name? How are the facilities well maintained? Is there equipment in good repair? Those kinds of questions about the survey. The surveys were coded numerically 1, 2, 3, 4, or 1, 2, 3, 4, 5, where 1 was the top box check mark, which is highest satisfaction. 5 was the lowest. Some of the questions were on a scale 1 to 4, some were on the scale 1 to 5. Again, 31,000 responses from across the country. The YMCA has longitudinal data. They do this every year. They've got a ton of data. It's one of the richest survey data sets I've ever seen. And this analysis was picked up in a book called The Power of Habit. If you've ever seen that book, fascinating book by New York Times reporter Charles Duhigg on habit forming, and he was interested in health, in people's health and how they can attain their health goals and fitness goals through incorporating habit forming techniques. And so that's why he contacted me about this particular issue, and I spoke with him along with the sponsor of this work, a man named Bill Lazarus of Seer Analytics. Seer Analytics is the company that holds all this data and does the analysis. So we had all these questions, 30 some odd thousand questions. I mentioned typically they were coded 1 through 5. The 57 questions that we included in the models, and I mentioned already that they were labeled as a 1 for the top score, 5 for the lowest score. And typically what we did for satisfaction is looked at ones versus all other scores. The data was generally very clean, which means we didn't have a whole bunch of nulls in the data. And so this is the layout of the kinds of questions we had. There are staff-related questions, building-related questions, equipment programs. The value for the dollar was question 22. Your relationships with other members were in a few questions. And this is just how the survey was chopped up, the way it was laid out with the text of the questions. So here are all the questions we had. And with these 32 some odd thousand questions, we used about half for building the models and about half for assessing the models. And the first question, how satisfied are you? 31% of the responders said satisfaction equal to 1, which is why we coded this from an analysis perspective as highly satisfied, satisfaction equals 1 versus all other answers. Because once you get down to the top 2, it was such a high percentage of the responders that it wasn't worth building models to see a 1 score or a 2 score. One of the interesting things is recommend to a friend, which was question 48, was 80, well, here what I write is, of the 31% who said satisfaction equals 1, 86% of those would also recommend the why to a friend. So a very strong correlation between those two questions. Likelihood to renew is another of the interesting findings, interesting questions, and 46% of the responders said likely to renew was equal to 1. They're highly likely to renew. So why do I bring up these three? These three were the core questions which we believed in analyzing the surveys were the target populations. What we're trying to understand the action of the individual member would be. Are they satisfied, which is often something we want to find out from analyses, and what characteristics of the why are most related to satisfaction. But recommend to a friend is very important as well. There is a fascinating Harvard Business Review article called The One Number to Grow On. And what they're arguing for in that article was recommend to a friend is how you grow as a company, not with satisfaction. Because recommend to a friend obviously is how you get more members or more sales, people who are willing to recommend to somebody else. Recommendations have such a strong emotional reaction with those to whom you're recommended to. And likely to renew, of course, is clearly related to the dollars. All three are interesting. I'm going to focus more on satisfaction, but not completely on satisfaction in this talk today. So here's our objective. We want to interpret the survey results. Some of the challenges we have. Missing values. I mentioned there wasn't much missing data, but there was still enough missing data that was problematic. And just very briefly, I'm just writing here that we imputed missing values in a way that had the least harm informationally. So what do I mean by that? What I mean is that if a missing value, if the relationship between missing values and those who are most satisfied could be computed, and it can, and a proportion of those with missing values, you can look and see what proportion were highly satisfied. We try to code numerically with that value that would make the most sense in the context of the other answers. So I'm going to make up some numbers. What if the satisfaction equals 1 was 32%, and satisfaction equals 2 was 16%, satisfaction equals 3 was 20%, and satisfaction equals 4 was another 20% of the population. And what if the relationship between a question and highly satisfied was that when that question answer was a 1, 50% were highly satisfied. And when it was a 2, 30% were highly satisfied. If the missing values relationship to the target value was 40%, we would code that as a 1.5, somewhere in between those two values. So that's just something we need to keep in mind. Why? Because the algorithms like linear regression, factor analysis, neural networks, all these kinds of algorithms require numbers. All of these numeric techniques require every value be populated, be filled. Because they all need to be filled, when we have nulls or blanks, we cannot use those for the analysis, which means we have to put something there. We could put a mean value, we could put some other value, but the approach we took here was to try to impute a value which made the most sense as we related that question to the target variable, like satisfaction. Another big problem is questions were highly correlated with each other. And this is so typical of survey analysis, where there would be blocks of questions that all ask a similar question, but in different ways. In fact, one of the great controls in surveys is to ask the same question in 3 or 4 different ways in different parts of the survey, just to see what kind of consistency there is with the responder. Because we know in survey analysis, there is a serial correlation that takes place between groups of questions. Questions near each other tend to get similar responses, even if you ask the same questions in different parts of the survey. They tend to be more related to where they are in the survey itself. So we want to be able to handle multiclinearity. And one way we can handle this problem of the correlation is with something that's called factor analysis. And I'll get to that in a moment. So another problem, the three target variables, satisfaction, likely to renew, and recommend to a friend. We actually, for some of our analysis, not all of it, but for some of the analysis, we decided to combine these three into one super question, which was the global target, which we call the index of excellence. I guess that's a pretty pretentious kind of term to use for this, but we combine those three, questions 1, 32, and 48. I'm not going to go into that so much now, but I'm raising it as something you may want to consider to combine. If there are 3 or more target variables which are interesting to you, you can provide a way to combine those into a single value you're trying to predict. And the whole point of the analysis is to look at the rest of the questions in the survey and relate them to the target variable: satisfaction, likely to renew, recommend to a friend, or in this case, the index of excellence. Okay, factor analysis. Now, like I mentioned at the very beginning, I'm not going to go into all the ins and outs of factor analysis. I put a reference here, and I'm going to describe it just in general terms. But factor analysis is a common statistical technique that's trying to find which questions are telling essentially the same story, which questions grouped together are correlated with one another to a degree that you can identify this latent factor, this latent super variable, which really is the same idea as is contained in several questions. And what we discovered was, from all these different questions in the survey, we identified a whole bunch of factors, and I've listed about 10 of them here. And let's see if I can use the pen to show some of the. Staff cares is one of the questions. That was one of the most significant factors that we found based upon the questions, which means several questions loaded up very strongly and into this one new factor that we labeled based upon the questions. We labeled that as staff cares. And here are the questions over here that were highly loading, highly related to the staff cares idea. But there are other factors as well, and I labeled 10 of these factors here. The staff cares, facilities were clean, the state of the equipment, the registration process, condition of specific equipment, et cetera, et cetera. So there are a bunch of different questions. Of course, parking is, with most of these surveys, is always one of those issues. You know, nobody ever writes back in their free-form comments, I just love the parking. You only get complaints about the parking, but not enough parking, the spots are too small, or something like that. Okay, so let me go to the next slide if I can. Let me clear this and go to the next question, next slide. And I can't go there for some reason. There we go, finally. Okay, and here are, for you numeric geeks out there, if anybody has used factor analysis before, these are the actual loading amounts on each factor. When you do a factor analysis or a principal component analysis, what happens is every question, and the questions are at the left here, has a loading on each of these factors. And then I colored in what's orange here, the highest loaders for each of these different factors. And then we assign the label ourselves to the nature of that question. So questions 8 through 12 were specifically very highly loading on the staff cares question, facilities clean and safe, equipment, et cetera, et cetera. So why do we do this? We could use all 57 of these inputs as direct inputs to any predictive model. However, what we decided to do instead was use factor analysis, and from these factors, use the factors themselves as inputs, because they summarize an idea in the data. So we can reduce the number of inputs, we can reduce the dimensionality, to put that in different terms, of the data, so that we incorporate fewer ideas, but fewer more specific kinds of ideas into the models. And so we took these factors And we actually took these 10 factors and 3 core questions. And these 3 core questions were questions 44, 22, and 25. Is value for the money was one of the questions that we kept on its own. And we used those as inputs to our initial regression models. Okay, so very straightforward statistical approach, 10 factors, 3 other core questions. What do we get out of it? So this is a flow of the process we went through. We started with all our survey questions. We identified the 3 key questions that I labeled down at the bottom. Is the why value for the money? Do you feel welcome at the why? And how much does it help you meet your health and fitness goals? And we believe that from an interpretation perspective, those would be fantastic variables to always include in the models. And then we also had the 10 factors. And so we had 13 input variables. We did some variable selection through stepwise regression. We get down to 7 inputs, and we had our final models. So very straightforward modeling approach. And here are the final factors that fed into the model, the 7 factors that loaded up into the model: facilities, equipment, value for the money. 2 staff questions: was the staff competent? Did the staff care about your well-being? Those are the ones that fit the best, fell into this final model. And you can see those 3 questions, 22, 25, and 44, all showed up in the final model, along with these 4 factors. One of the nice things about those factors, I might say on the side, is they incorporate different kinds of ideas. So you've got the monetary side of your experience with the why, you've got the facility side, and you've got the relational side, all a part of this model. So we were really happy about this. In fact, we're so happy about it, we thought, hey, let's come up with this great visual to describe all these different characteristics. And this is, I'm showing some really old data from the models back, 15 years ago. But we have these 7 factors. Here are those 7 factors. I'm going to go back a slide for just a moment, so don't freak out. Here are the 7 factors and the descriptions that fell into the model, and those are all here in this chart. Every one of those factors is important to the model, and we thought, what would we want to know for an individual YMCA branch? So that, okay, let's think through this. Well, the relationships are important, the goals are important, but what if we compared the values for a particular branch with other branches that were like that branch? So a side analysis outside of this analysis I'm showing you here, we found the San Diego YMCAs are a lot like the Denver, Colorado YMCAs, which are a lot like the maybe the Reston, Virginia YMCAs. Similar sizes, similar demographics, those kinds of things. So we could compare them to their peers. We could also compare what the models predicted year over year for those particular branches. So if it's green, you did better this year than you did last year. So we're comparing to the peers, we're doing year over year, green is good, red is bad, all these dimensions. In fact, I'm not going to go through every single dimension, but this was a 45-dimensional picture. And I was really happy with this. I thought, this is so rich, so informative. And what did the stakeholders say to this? What in the world are you talking about? They did not follow this. This did not scream transparency to them. They did not understand exactly the message that was being told here. So we went back. And this slide is just describing the axes. And this slide, if you go back over this later, is describing all the different dimensions of the chart. So here's the problem. The customer did not care about the slick visual. They want to know what action they could do. They want to know, hey, my YMCA has competent staff as a problem. I need to know about that, and I need to know what to do about that. So we started thinking about that again. We thought, well, let's take a different approach. Regression neural networks are fantastic models. They're global estimators, which means you build one model that describes everything in the data, and that's what we're showing so far. However, what about a different approach? And this is a picture from a survey by Regression Analytics. I've got the link here. It's a great survey of all kinds of characteristics of data scientists, who they are, where they live, what kinds of models do they build. And here, one of the slides is what kind of algorithms do they use. The thing that I find fascinating is every year this survey has been done, these techniques are at the top of the list: regression, decision trees. So what I recommend to people who are starting out in the space, starting out in data science or predictive modeling, is focus on a few techniques first, like linear and logistic regression and decision trees, and learn them well so you can build models effectively using those kind of techniques. Those are by far the most popular ones, and one of the reasons is they're simpler to build, and in the case of decision trees, they're easier to interpret. And that's what we want to get to. Each of these techniques that are on the prior slide do slightly different things with the data. This is showing decision regions for a data set I won't describe here, but the main point of this slide is to show the shapes of the decision regions are different for logistic regression and neural networks compared to, say, naive Bayesian decision trees. They do different things. So it's good to learn different techniques like regression and decision trees because they describe the data in different ways. So we're going to focus on the decision tree idea here. And decision trees are very popular because they're easy to build, simpler trees are easy to interpret, and they can find nice interactions between variables in your input data. And by interactions, I mean in the form of if-then-else rules. So this decision tree at the top right was built on the Titanic data set. So we're looking at who survived on the Titanic. And if you're female on the left and you're a first-class passenger, 97% of the passengers who met that rule survived. Very easy to interpret. However, if you were male and you paid very little in your fare, between 0 and 14 shillings, 13% survived. Now, your luck wasn't quite so good. So the decision tree automatically found the best ways to carve up the data into a set of rules that describe the characteristics. That is much more understandable by decision makers. So here's what we found with this data, the satisfaction model. This is a decision tree that split first on feel welcome. So it was saying, if you feel welcome coming to the Y, that's the best way to split up the satisfaction model. So the more welcome you feel, those who check the 1 box for feel welcome were much more likely to check the 1 box for satisfaction. And you could follow these rules down to what we call the terminal nodes. The terminal nodes here are numbers, and you can think of them as buckets. Buckets that the rules describe in the data in a way that if you match the rule, you'll fall into the bucket. So if question 25 equals 1 and question 13 equals 1, the top drawer, which is facilities are clean, and question 2 equals 1, then you're most likely, then you'll fall into this bucket down here at the bottom right. Question 3 is facilities are clean. Question 13, I should say. Question 22 is value for the money. So one of the things that came out of this is if you don't feel welcome and the facilities aren't clean, you are not likely to be satisfied with the Y. So let's look at some of these rules. Terminal node, number 1, the best terminal node was this. If you strongly agree the facilities are clean and you strongly agree that member feels welcome, then you're highly satisfied. And what the terminal node describes with that population that matches that rule, then again, the decision tree finds this automatically. You don't have to build this. It's induced, it's built from the data. It discovered that of the 10,000 surveys that matched this particular rule, 7,289 were highly satisfied. So 72% were highly satisfied. So if you remember, 31% of the overall population initially were highly satisfied. So this rule is saying that you're twice as likely, more than twice as likely, to be highly satisfied if you believe the facilities are clean and if you feel welcome. So you go there, you feel like you belong in this location, and you look around and it looks like it's well taken care of. Bingo, you're there. Now, what else is very important with this is this. 49% of all the highly satisfied members of the Y in this data set match this rule, of the highly satisfied match this rule. This is almost half of the highly satisfied ones. That says something very important for the local branches when they're looking at this kind of rule. They say if you can flip people from moderately agree facilities are clean or moderately agree they feel welcome, if you can flip them into this category, and this is the most common way members feel highly satisfied, if you can flip them, you'll be much better off, more highly satisfied members of the YMCA. The second best rule here, what I called the second best in terminal number 2, if you strongly agree that you feel welcome and strongly agree that it's good value for the money, even if you don't strongly agree that facilities are clean, then you're highly satisfied. So there's a subpopulation of those who feel welcome, but they don't think the facility is necessarily really clean. But even if that's the case, as long as it's good value for the dollar, they're willing to trade off the cleanliness for value and still be highly satisfied. 50% of those who match the rule are highly satisfied, and that's 15% of all highly satisfied members. Now let's think about one more thing here. 49% were highly satisfied with terminal node 1, 15.6% were highly satisfied terminal node 2. That's almost 2/3 of all the highly satisfied members followed these two rules. Clearly, and I'm going to go back a slide now, feeling welcome is tremendously important. Following here, feeling welcome, facilities are clean, that's terminal node 1, here's terminal node 2. That even if the facilities aren't clean, as long as value for the dollar, you're still highly satisfied. So here's the point with all of this. This is a much more transparent way for the local branches to understand what's going on with their population. Strongly feeling welcome was such an important part of this analysis. Strongly feeling welcome, the very first split, was a key driver of satisfaction. So what does that mean? That means when you come into the Y, that person, when you're scanning your card, they should be trained to make you feel welcome from the get-go. All the staff should be welcoming people when they come in to make them feel like they're a part of this Y. When they have a problem, to address it. When they see them, greet them, all those kinds of characteristics. That's an immediate and very transparent way for them to improve satisfaction at the Y. Here's the third rule, which was kind of interesting. If you strongly agree that the Y is the right equipment, and again, strongly feel welcome, and somewhat agree the facilities are clean, even though you don't strongly feel it's good value for the money, then you're highly satisfied. So there's another mitigator that as long as the equipment that you want is there, even if it's not the cleanest Y in the world, and even if it's just kind of an okay value for the dollar, you're still highly satisfied. And that's another 6% of the population. Okay, hopefully that makes sense. Now,
so
go ahead. Yes.
On that note, we do have a question and it does make sense, but we have one that's tied right into this slide, so I wanted to break in. And the question is, how are the key rules in the tree selected, i.e., how did you determine that clean and welcome should represent one of the 3 key terminal nodes?
Okay, so that's a good question. So the way decision trees are built are like this, and I don't have a, you can't see me as a lecturer, so I normally do this with my hands. So I'll describe what my hands are doing. So imagine in your mind an Excel spreadsheet with, in this case, we have 13 columns of inputs in this data, and we've got a 14th column, which is the target variable, which is satisfaction, okay? All 13 columns are candidate inputs. What the decision tree does is this. It starts from scratch. It says, look at all 13 of these columns, find which one does the best job at splitting the data into subgroups so that those subgroups are more strongly related to satisfaction or not satisfaction. Or to put in a more mathematical form, split the data into subgroups for each of the variables so that you have a higher proportion of satisfied members on one side of the split versus the other. So here's 25, and it's splitting the data. It's looking at 25 and saying, how can I best split 25 into two subgroups that maximize the differences between those populations? And it picked feel welcome equal to 1 as the way it's split. Now, it tried all 13 of them, and it assessed all 13 of them, and the tree algorithm itself determined pick feel welcome. That's the best way to split the data into subgroups. Bam, we split it. So now question 25 is done. Now the next step in the decision tree is to say, now let's go over to this side. And now from the data remaining from the question 25 equals 1 subpopulation, assess all 25 variables. And remember, question 25 only equals 1, so it's not going to be interesting. But for the other 12 questions, what's the best way to split the data into two subgroups? And it picked out, of all 12 possibilities, question 13 was the best way to do it. Bam, do the split. Then it got down to this population where the terminal node 1 is. That's this terminal node population with 10,000 surveys. And it said, try to find a way to split this population into two subgroups that maximize the difference between ones and zeros, satisfied and non-satisfied. And the tree algorithm thought, you know, there's no real good way to do that anymore. So it stops. So everything you see in front of you was induced automatically by the tree through a sequential, stepwise, one variable at a time selection algorithm. And I hope that makes sense. And if you can type yes or no. And if it doesn't make sense, follow up the question in before we end today, and I'll be happy to write it out in an email or point you to other information on how decision trees are built.
Yeah, I will. I'll circle back at the end if I see any follow-up to that.
Okay. Let's look at the other side. Let's look at the worst, the lowest satisfied shoppers. Let's see if I've got that. Here's the unsatisfied rules. Terminal node 15, 19,000 surveys, 40% of the population. If you don't agree the staff is efficient, and you don't agree that you feel welcome, and you don't agree the facilities are clean, then those members are only 8.3% of those members were highly satisfied. So you're about 25%, 1 in 4 as likely to be highly satisfied. What I want to know is, who are the highly satisfied members who think the staff isn't efficient, you don't feel welcome, the facilities aren't clean, and all those things are true at the same time or not true at the same time, yet you're still really satisfied? Well, maybe it's like me. I'm a member of a Y. I play basketball. Even if the staff didn't care about me, even if they didn't notice me, even if the rest of the facilities weren't clean, as long as the basketball court was open, I'd probably be highly satisfied and with the other guys there. But anyway, that's 58% of all the not highly satisfied members of the Y fit that rule. And another rule was, if you don't agree the facilities are clean and you don't agree with the Y is good value for the money, even though you feel welcome, they're not satisfied. So they may feel welcome, but the facilities are lousy and it's too expensive and they're not highly satisfied. Maybe they check the 2 or the 3 box for satisfaction. Let me go through a couple others, because it's interesting the differences in what the algorithm is finding. So as I mentioned before, the decision tree algorithm finds all these splits on its own. We're not telling it what to look for. We're not telling, well, let me be crystal clear. We're telling it what to look for in that we tell it the target variable and we tell it the input variables. We don't tell it how to associate the inputs with the target. So in this case, the recommend to a friend model still used feel welcome, but the most important split was the question about loyalty in the data. So if you are loyal to the Y, and if you feel welcome, you are likely to recommend to a friend. So let me go to that. If you feel loyal to the Y and you feel welcome, you strongly agree that you will recommend to a friend. That's almost half of all the recommendations, strong recommendations. And that's 88.6% recommend rate. 88.6% of everyone who filled out a survey who said they were loyal to the why and they feel welcome said they'd be willing to recommend the why to a friend. That's phenomenal. So what do you do operationally? Again, if you have members who don't feel welcome, if you can flip them from a 2 to a 1 by training your staff better, you can flip how likely they are to recommend to a friend significantly. That's the operational way you can deal with this. So the terminal note 2, if you strongly agree that you're loyal to the why and the why is a good value for the money, even though you don't feel welcome, strongly feel welcome, then you're likely to recommend to a friend. Again, that's 18.4%. And then the third rule you can read over here. Good value for the money, you feel welcome. Even if you're not loyal, you still are likely to recommend to a friend. So these are all 70+% likely to recommend to a friend. And the total of all of these strong recommends is 47 plus 18 plus 6. So that's 71% or so are of all those who strongly recommended fit one of these 3 rules. And that's phenomenal. That's almost 3/4 of everyone who'd likely to recommend to a friend is represented right here in front of you. Third model, intend to renew. What defines this? And you'll see one other factor that strongly showed up here for your likelihood to renew, and that's meeting fitness goals. So satisfaction, I'm going to kick back to satisfaction just for a moment. It's about feeling welcome, yes, the value for the money and the facilities themselves. Now, if you're likely to renew, what comes into this now, sorry, wrong slide, fitness goals is more important. So here, the strongest rule is this, 74% likely to renew, almost half of all those who are highly likely to renew said that they feel welcome and the why help meet their fitness goals. Now, is that obvious? Maybe. If you'd ask stakeholders at the why if these are important characteristics, maybe they would say yes. However, what they probably didn't know was how influential this was, almost 75% likely to renew if these are true. And what they probably also didn't know is this is half of all members who are likely to renew had this characteristic. Phenomenal. And also the second rule, if you're strongly agree that why is a good value for the money and you feel welcome, even if you don't strongly agree that it meets your fitness goals, then you're likely to renew. So it's a good value. It doesn't do the best job at helping you meet your fitness goals, but it's still, it's a good deal. And you feel like it's a part of your family, part of your home to go to this particular why. That's 8% of all likely to renew. And here's a third rule for renewal, and that's 15%. So once again, 65, that's over 75% of all likely to renew are represented by 3 rules. Very easy to understand. And before I close out for other questions, I want to bring up a couple other aspects of this. When you look at which questions are driving these analyses the most, you hopefully what you saw is feeling welcome was the most, if you were to pick the most important answer to the questions in the survey that drives these key outcomes, it's feeling welcome. It was a primary splitter for the satisfaction model. It was the second level splitter for the recommend to a friend. It was the primary splitter for renewal. Help meet fitness goals showed up in the recommend and renew models. And value for the money also showed up in the recommend and renewal models. So there, and value for money also showed up in the satisfaction model. That number got moved from this. So there are a few questions that are driving a lot of the representation, but there are some other questions which are specific to particular characteristics. I mentioned the loyalty question. How loyal you are really strongly ties to the recommend to a friend model, and only that one. So put another way, The key drivers of satisfaction were facility cleanliness, feeling welcome. For renewal, it was fitness goals, value for the dollar, feeling welcome. For recommend to a friend is value for the money, loyalty to the why, and feeling welcome. Again, feeling welcome was important for all these things. And I'm just going to state the obvious again. The key to this from the practitioner standpoint, for the modelers, from our perspective, is that all of these associations, all of these characteristics were discovered organically, or a lot of times we'll say we induced them from the data. The data, when you hear people say, we need to let the data speak, make the data tell us stories. Well, in this case, the data was telling stories. The decision trees teased out of the data by the algorithm without us guiding the trees, just organically from the algorithm, the trees themselves determined satisfaction rules, renewal rules, and recommend to a friend rules. TN stands for terminal node here, and this is just showing that same story I was mentioning before, that 3 rules for each of these models drove 70 to 75% of all of the satisfied members, all of the renewal members, and all the recommend to a friend members. So that is tremendously valuable. That means in 3 simple rules, decision makers and stakeholders can get an idea of what's driving the behaviors and driving the intent of members to the YMCAs. That means they can enact programs to try to change the perception of people, members within the Y. So going back a slide, feeling welcome I've already described. If the clean facilities is an issue, then changing perceptions from a 2 to a 1 and how clean the facilities are can move the needle on satisfaction. Value for the dollar. How do you change value for the dollar? Of course, you can have different renewal amounts or slow roll increases in dollars. You can also, for renewals, help members meet their fitness goals. Talk to them about what their fitness goals are, help them achieve their fitness goals, flip them from a 2 box to a 1 box to increase renewal rates. So in conclusion, the best solution is not always a good solution. And by that I mean this. The best quote unquote statistical solution, building the factor analysis and the regression models, that may be considered a good standard practice, but in this case, it wasn't what the end customer, what the decision makers thought was best. So instead, we built a good solution that was more transparent, helped them understand better what was going on with the data, told better data stories for them. We learned from iterating. Sometimes the first and second pass to a solution may yield interesting information, but we learn from the modeling approaches. We learn from what we see in the models as we try to formulate what's best, what solution would be most informative. So sometimes it takes several cracks at this nut in order to find a good solution that will help the decision makers make those better decisions. And third, don't give up. Matching the data to decisions is difficult business. It's rare that I go in and talk to a stakeholder about building predictive models that they're able to articulate to me exactly what they want those models to look like. What kind of model do you want? How do you want it to be reflected? What stories do you want told in the data? They usually say, well, let the data speak. Help me understand what's in the data. So sometimes it takes persistence on our part to build a model, explain the model to the stakeholder, see them scratching their heads, and go back and try with a different approach until we can make those connections. And I think we're out of time. I'm happy to entertain any last questions.
So we do have at least one more, and folks, this is probably your last chance to get a question in. So we do have one more. It's let me make sure I've got this selected right. It says satisfaction, renewal, and recommend. The algorithm selected those, correct?
The algorithm used those to build the trees, but we as the modelers, along with the decision makers, decided that those 3 ideas, those 3 columns would be the target variable. So whenever you build a logistic regression or a neural network or a decision tree, any predictive modeling technique needs input columns, and they need what I was referring to as a target variable column. And so one of those columns in the data was satisfaction, 1 or 0, or more precisely, does satisfaction equal 1? If it's yes, then we code it as a 1. If satisfaction equals 1 is false, we code it as a 0. That's a literal column in the data. The job of the decision tree was to take those input columns, those however many input columns we have available to us, and try to find ways to associate them together to predict that other column in the data that we told it to look at, which was satisfaction, or intend to renew, or recommend to a friend. So we told it the data, what the data is. What the trees did was find the associations between the inputs and those questions of the survey and those target variables.
Okay, we've got a couple more, one of which I can handle. So a couple of folks asked if this was going to be available on YouTube. I don't believe that to be the case, but there will be a recording that should be up by the end of the week, and you'll get an email about that. There was a technical question said also asking you what package/software was used and when you had completed this, and is it recent?
Oh, so this analysis was done a while back, like 15 years ago. But the software package I use is still available today. It's called it's the CART algorithm. The decision trees come in multiple flavors, and one of the most popular flavors is called CART, C-A-R-T, classification and regression trees. The other flavors of trees are the most common ones or popular ones are C5 and Shade. I have a deck that I can make available to this audience that I'll coordinate with Matt on that gives some description of those different tree algorithms, what's the differences and similarities between them. But Salford Systems, now purchased by Minitab, is the owner of that particular software package, which I just love. It's a fantastic way to build decision trees, easy and gives good diagnostics and interpretation of the trees themselves. But decision
Okay.
trees, you can get CART decision trees in R. It's called RPART, the letter R, P-A-R-T, which is short for recursive partitioning, because decision trees are recursive algorithms and they're partitioning algorithms. So you can use the R function, RPART.
Okay, we've actually had a couple more come in, and since we've got 6 or 7 minutes here, I'll toss those your way as well. Said, what program did you use to determine the next best predictor question?
So I think what you're referring to, if I understand correctly, is I had feel welcome for this intent to renew model, and we've got the tree that's built that you see on the left. I put these things called surrogates underneath. That's something that comes out of the CART software, and only the CART software as far as I'm aware, that says if feel welcome was not available, which column in the data would you choose that splits the most like the winning split? And that's the surrogate split. So you can see that oftentimes the surrogate split is a question near the winning split. And that's because of that correlation effect I was describing before, that nearby questions are correlated with one another. So if the question was about those surrogate ideas, that's where those come from. It's a part of the CART software package. I don't think it's a part of RPART, but it's a part of the CART software package. If the question was referring to in the next best, like the second, third, fourth splits, or when I talked about terminal node 1, terminal node 3, terminal node 5, the best way to describe intent to renew, the second best way, the third best way, those are just what comes out of the tree. These 1, 2, and then the next terminal node was down here. That's just what comes out of the tree organically. You can sort the reports of terminal nodes on any number of factors that describe them, such as the percentage relationship to the target variable, what percentage of those records that match the rule are intended to renew. You can also sort them by the population size, which I was looking at both of those to identify which terminal nodes I thought were interesting.
Okay, it looks like we've got one final one, and the question is factor analysis PCA, and actually we just had another one coming after that. So
Okay, the answer is no, but they're very strongly related to one another. One of the key differences between factor analysis and PCA, principal component analysis, all the inputs are necessarily by algorithmic design orthogonal to one another, which means they're independent of one another, which means after the principal component analysis decomposition into those factors is done, the correlation coefficient between those factors is 0. Factor analysis, depending on the flavor of factor analysis you use, does not necessarily require that. So it's a slightly different way of describing the factors, but they're very closely related. The interpretation is very similar between the two.
okay, and I think the last question, because we are closing in on time, is any recommended books, YouTube links, or other kind of study materials to build on some of the things you talked about?
Yes. Okay, so another thing I'll do for this, I'll put together a kind of a packet of links specifically related to decision trees, as I already mentioned, and also related to predictive analytics. Matt will figure out what's the best way to communicate that to all of you on the website. I'm happy to do that, and without being too self-serving, everything I was describing here, including this case study, is in my Applied Predictive Analytics book. Including a chapter on a large section on decision trees and case studies at the back of the book. This is one of the case studies I describe in more detail, this particular application. There are other books that I'll recommend as well. There's a Data Science for Business. That's an excellent book by Foster Provost and Tom Fawcett. Phenomenal authors, very clearly written and kind of at that mid-tier technical level like this. My style is more of a mid-tier technical. There are more technical books out there too, which I'll reference in the notes that I'll send to Matt.
Okay. Well, thanks. I don't think we have any other questions, so let me go ahead and if you could get to the slides to set up the next one. Thanks everybody for coming. Thanks for your questions. I think this has been good stuff. And now, of course, stay tuned for our next session, 4 Paths to Data Science Success using Microsoft Azure with Brad Llewellyn. Thanks again, and we'll see you on a future session. Thank you, Dean.
Thank you.